So this is the architecture, the proposed system architecture. As you can see it here, figure. So I don't know the figure, so I think you put the figure number there. So the proposed system architecture. So, and of course it's divided into 3 different stages or phases. Sorry, data preparation, then testing and evaluation stage phase, and the last stage is testing or deployment. So is that okay? So now let's start with data preparation. Data preparation involves the process of gathering, collecting data from different sources, integrating them, pre-processing them, and then getting a kind of suitable data that we can use to train our proposed model. So that's just what data preparation is all about. And of course, when you look at it, you find that we have different stages now. So it means that we are going to be collecting data for each of the stages. So there is going to be infected breast, okay, with cancer, stage 1. So data set, we collect that one. Then we collect data set for stage 2, cancer, stage 3 and 4, respectively, like that. So now when you look at this place, you see different pieces of information here. They are data sources. So the mindset behind that is that we are looking at it from the perspective that we might not be able to get the size of the data set that we need to train the model from one particular source. Okay, so that's why we're having different sources. So we are integrating this data from different sources for stage 1. The same thing applicable to stage 2, the same thing applicable to stage 3 and 4, and even the data set with no infection. So we are collecting them. So the assumption is that we are going to be collecting this data from different sources. Alright, so that's just what these ones they are all about. So then we need to reintegrate these data sources. Because the essence of reintegrating them, initially we're thinking that okay, we'll be training our model based on these stages. But it's not going to be, it's not really logical in that manner. So what we want to do, what we are proposing is that we collect this data, integrate them together. So each of the stage now, from stage 1 to stage 4, and even including no infection data set. So they are going to form different classes. Alright, so that when we are done training, by the time we pass, we want to test the system in real life use cases. So the system should be able to tell us, okay, this particular breast is infected, but what about if a breast is not actually infected, or possibly after treatment? It's possible that maybe the cancer has been cured totally. So the system should be able to tell, the model should be able to tell us that, okay, this particular breast is no longer infected. Alright, so that's the essence of this particular, the last data set here. Okay, so we integrate in data together, and that's why we label this one as integrated data. So the integrated data contains all the classes of these breast cancers, okay, according to their stages. So then we pre-process that, or the data set is going to be pre-processed in order for us to have a suitable, because we can't just pass the image raw into the model like that. It doesn't understand the pictures or the images. So we have to process it and convert it into a suitable form for training. So that's what this pre-processing is actually is proposed for. Then the result of this one is going to be pre-processed data. So we now have data set that is suitable to train the model. So that's all about data preparation. I think that one is clear. Then moving on, training and evaluation. So we now have enough data set. Then we can simply, that's because we have already pre-processed that, then we can simply pass it to the neural network model. And the neural network, the name of the neural network model we are using is convolutional neural network with attention mechanism, CNN-AM. Okay, and so it is modeled here diagrammatically. So this is convolutional neural network with attention mechanism, as we can see here. So this is a pre-process. This one is just representing a visual representation of the pre-processed breast images, whether with cancer or without cancer. Is that okay? So we pass it to our model. Then during training, so after we have trained, we have to train several times. Okay, so during training we continue to evaluate using maybe based on performance metrics such as maybe accuracy, precision, F1 score, and so on, depending on the kind of matrix that we want to use for our evaluation. So after we have gotten what we wanted from the evaluation, then we'll now the output of this one is going to be a trained model. So we have trained it and we have evaluated it. We are okay with the evaluation. Then the output is our trained model, as you can see on the screen here. Then the next thing is to deploy the model, right? So the last stage here is deployment or testing. Okay, so now that we have a trained model, so we can easily test it with real life use cases. Okay, so this is an example of a use case. Now our input image is an image of human breast infected with cancer. Okay, so now we pass this into our already trained model. Then as you can see from this place, under the prediction here, we have about 5 classes. The one with no infection is labeled as nil, stage 1, stage 2, stage 3, and stage 4. So according to what the model has seen from the image here, is saying that it's predicting this particular breast, this image now, as stage 3. So it means that this particular breast is infected, not only infected, but is the cancer, the status of the cancer in this breast now is at stage 3. So that's what this model is at. So this is just a kind of model. So that is just everything about the system architecture. I don't know whether it's clear. So let me just summarize again. So we collected data from different sources, okay, for each of these stages. Stage 1 from different sources, stage 2, and so on and so forth. Then having collected for all the stages, so we now integrate the data together, and that's why we label this, as I said, integrated data. We pre-process that. The output of the pre-processing is pre-processed data, clean data that the neural network can be trained with. So then we pass that into our neural network for training, and of course we need to evaluate it to get to be able to evaluate the model. Okay, so we evaluated that, and then when we got what we wanted, talking about accuracy, precision, recall, and F1 score, then we fix it and it becomes what we call a trained model. So we now have a trained model that will be able to predict the status of whether a particular breast is infected and at what stage is the cancer, the status of the cancer in the breast. So we now have that. So now to test it, now the last phase is to test it with real life scenario. So this is an image of a breast, okay, possibly infected with cancer, and of course, as we can see from the diagram, these are trained model already, then evaluated and trained. So now this is the image of a breast, and of course we pass that to our trained model, and this is the prediction it's giving us. It's saying that the model, according to what we are seeing in the diagram here, the model is actually saying that in this particular image, I've seen that this particular breast is infected, and not only that, it has the status of the cancer in this breast is at stage 3. So that's just the proposed system architecture. That's how it works really. So then talking about the aim and objective of the study. So the aim is the title of the thesis. So as you can see on the screen, the major aim of this research work is to develop an automated assessment system for breast cancer staging and treatment response using convolutional neural network and attention mechanism, CNAM. So then we move on to state the objectives. So by saying the definite objectives of this research work are to 1 or A, design a CNN attention mechanism based multi-stage breast cancer detection model, as we can see, as we have explained in this proposed architecture. This is the model, the CNN AM based multi-stage cancer detection model. So then next to that one is to implement it. So when you implement, you'll be able to deploy. So that's what happened here. We implemented this, then we have a trained model. So then we deploy that. So after implementing it, so when we implemented, then the next thing is to evaluate. As you can see here, we did implementation. When you are implementing, you are actually training. So the implementation will be done using Python. Okay, so during training, at the same time we'll be evaluating, so that we'll be able to know that okay, this one has given us what we actually want, talking about the performance matrix. All right, so we implemented that. Then next to that one is to evaluate, and after evaluation we can deploy. So that's why we put deploy the model for real life use cases. And of course, this is a real life scenario. This is a real life breast image that we pass to the trained model, and of course it's able to tell us that okay, this particular breast is infected and is at stage 3 cancer. So that's just all about the proposed system architecture and then the aim and objective of the study. If there's any other further question, please let me know. Thank you.